All right, ready? Let's talk about forms of energy. So what is energy? Well, it's the capacity to do work. Don't worry so much about the definition. Let's talk about it more. So what are some forms of energy? Whoa, that's a lot. So you can see a lot of information here. You could come back and look at this. This has some great information, but let's kind of look at it. We have thermal energy. That's the energy in a system that's responsible for its temperature. Heat, which is the flow of thermal energy. Remember, it flows from a warmer object to a cooler object, the one at high temperature to the one at low temperature. Special note, temperature is not a form of energy. Temperature is a measure of a type of energy, average kinetic energy, but temperature itself is not a form of energy. Important to remember. Nuclear energy. So that's energy within a nucleus. So we can have fission, which means splitting up a big nucleus. That's what happens in nuclear bombs, but also what happens in power plants. Or we could have fusion, which is joining two smaller nuclei, and that's what happens in stars, like the sun. We have light and radiant energy, sound energy, electrical energy, moving electrons, magnetic energy, and then we have electromagnetic energy, which is visible light, but also things like X-rays, gamma rays, radio waves, and more. We have chemical energy that's stored in bonds, mechanical energy, which is kinetic or potential. Kinetic is the energy of motion, movement. Potential energy is stored energy, usually due to the position. The law of conservation of energy is important. It says that energy cannot be created or destroyed. It can change form. So if you look, the total amount of energy up here, total amount stayed the same, but energy here moved from the surroundings into the system. So the amount of energy in the system went up and the amount of energy in the surroundings went down, but the total amount of energy stayed the same. That's the law of conservation of energy. Energy cannot be created or destroyed. The total quantity of energy remains the same. Energy can change form, though. So here you could see the total amount of energy remains the same, but the amount of energy as potential energy and heat and light energy is varying, but the total amount of energy remains the same. Energy can change form. That's important. Remember, according to the law of conservation of energy, the total amount of energy cannot change, but the energy can change form. So we could go from chemical energy in gasoline to mechanical energy movement in a car. We could go from potential energy as the apple is sitting on the tree to kinetic energy as it is falling from the tree. We can have a car that changes chemical to mechanical energy, also heat energy. We can have an electric mixer that changes electrical energy to mechanical energy, but also heat energy. It gets warm. Okay, so lots of types of energy conversions. Here you can see in a television. So we have electrical energy that's being converted to radiant or light, sound, but also some thermal energy. Energy changes form in physical changes. So any kind of phase change is a physical change, but there is a conversion of energy. So a solid has much more stored potential energy. A gas has less potential and more kinetic, more movement. Okay, so you can see here's a phase change. Okay, there is still energy conversion. Energy changes form in chemical changes as well. So in glow sticks, chemicals react to produce light. In cellular respiration, we break down complex molecules and get kinetic energy, heat. In photosynthesis, light or radiant energy is used to convert it into chemical energy or stored energy. Remember, again, temperature is not a form of energy. It is a measure of another type of energy, but temperature itself is not a form of energy. And there you go. That's forms of energy. I hope you learned something new today.